Hey everybody, let's dive into this example. One important thing to keep in mind is when you're doing an example that gets pretty busy like this, you might want to remind yourself that, for one thing, the negative could be looked at as a -1 sitting in front of that 2. Next, the 2 and the 3 should be looked at as having that invisible 1 exponent. I know that 2 and a are quite close to each other, but the 2 is not part of the a, which is raised to the 3rd, unless of course they're in parentheses. So that being said, -1 on the inside, 2 to the 1st on the inside, a to the 3rd, b to the 2nd, c to the 0. I hope we all just know that that's 1. Over, I'm rewriting it just to point out a few details, 3, or 3 to the 1st, times a to the 2nd, b to the 3rd, and c to the 7, all being raised to the -2nd power. Can we start handing out this 2nd power to everybody, or -2nd power to everybody on the inside? Sure, but. Think smarter, not harder. I would simplify inside first. Totally allowed. That's the P in PEMDAS, basically. We're dealing with what's inside of the parentheses first. 2 and 3 are already reduced, then that -1, not much to do with that. 3 A's on top, 2 A's on bottom. Reduce, knock them out. How many are left and where are they? 1 is left on top. So -1, 2 to the 1, A, or A to the 1, B to the 2, B to the 3, B times B, B times B times B. Knock them out. How many are left? And where are they? 3 to the 1 on bottom, B to the 1 on bottom. That C to the 0 is gone. It was just 1. And that C to the 7 is on bottom. A couple other options. And I'm going to try to always present these things to you in different ways so you know you have options, there's flexibility. If you have a -2nd power, what we can do is, to make this a positive 2nd power, just replace your numerator with the denominator and replace your denominator with the numerator. Find the reciprocal, flip this whole thing inside. So what's that going to look like? I'm glad you asked. 3 to the 1, B to the 1, C to the 7, over -1. We can, I'm just going to leave it as -1 right now. And 2 to the 1 and a to the 1. Now it's to the positive 2nd power. And some of you might be wondering, but the -1, what's going on? I thought things, when they flip, it became positive. That's not an exponent. The exponent would change. Okay, but in this case, what we did is we kind of took that negative, or -1 from the 2, gave that to everybody, and flip-a-roo, and we're going to start from here now. So I'm just going to go from here on a little adventure, and we're going to pick up right over here, okay? So 3 to the 1st, to the 2nd. This is a power of a power, right? We have them kind of Russian nesting doll style, one inside the other. When you have this situation, we multiply our exponents. 1 times 2 is 2. That means we have 3 to the 2. We have B to the 2. C to the 14. On the bottom, in our denominator, -1 times -1. I like to pull it apart because when that negative is with the 2, I feel like you guys start making up your own rules. Just -1, okay? -1 squared, -1 times -1 is +1. Then we have 2 to the 2nd and a to the 2nd. Anything left to do? Well, of course, I would evaluate the constants raised to a power, especially because they're so small. And these dots are not necessary. I'm just trying to, like I said, present it differently each time. And you'll have 9b squared c to the 14 over 4a squared. when you're done, there's no need to check if you could reduce, as long as you are sure you fully reduced before you raised everything to a power. So if you reduced, say you had 4/6 and you reduced it to 2/3 and then you squared it. Side example, 4/6. Oh, well, that equals 2/3. Great. But what if it was raised to the second? And you went that away. Great. What would be next? 4/9. See? Nothing to reduce. But what if you didn't reduce it, 4/6, and you squared it? Well, we would get 16/36, which we could reduce, right? Looks like we can get a 4 out of both of them. 16 is 4 times 4, and this is 9 times 4. So if we reduce, oh, look what we get, 4/9. So instead of reducing and dealing and playing and fixing and simplifying big numbers, just simplify right away, then deal with your exponents. All right? Hope this was helpful. Hope you are a property of exponent rockstar, and have a great day. Any other playlists that'll help you with properties of exponents will be attached at the end. This is the last example. So good job.